Hello viewers, welcome back to the Moose Mobile Auto Repair channel, and today I'm going to be showing you on how to do a starter draw test to test the amperage from the starter to see if it's healthy or if there's a problem with it. Our test vehicle is a 2009 Pontiac Vibe, and it has a 2.4 liter engine. At one point I thought that there was an issue with the starter motor because it was making a strange sound as soon as I let go of the key, and then it was making a weird noise. But it doesn't happen all the time. But other than that, it seems to be cranking over normally, and the engine seems to be starting okay. So I have some test equipment here, so I'm going to test a starter to see if it's okay. So right now I could either use an amp clamp to check the amperage for the DC amps, or you can use a special tool to test for the amperage draw. Now this device I have here is a Fluke 337. It's capable of checking the amperage for any device such as the alternator or the starter or the battery. So right now I have the machine hooked up. I've already charged the battery, and I also have an amp clamp that comes with the kit. I connected it to the positive of the starter here. I connected the amp clamp here on the starter cable. The cable is hiding behind here. You can either connect it to the positive side or you can connect it to the negative side. So over here I'm using an old machine. It's the Snap-on Micro VAT a tester. It's capable of testing batteries, alternators, and starters. So I'm going to turn the machine on. It's a very old machine from 2001. So I'm going to go to individual test, and we're going to go to the starter test. We're going to do the extended test. Just ignore that. Disable ignition. I already I removed the EFI fuse for the fuel system, so that's all done. I'll show you guys on where the fuse is later after I'm done with the testing. You know, it's saying to start cranking engine. So I'm going to crank the engine over, and then we are going to see the readings. And now again, this is a fully charged battery. I had a battery charger on it already, so it's already 100% charged. So I'm going to crank it over now. So it said that the cranking voltage is normal, 11.26 volts. I'm going to scroll down, battery voltage. It applied a 50 amp load to the circuit. I'm going to check cranking voltage. It says average 11.26 volts. minimum 10.98. I checked the spec on service information. It says should be a minimum of approximately 11.5 volts or more, according to the specifications. So it's a little slightly low. It's a little bit off, but I don't think it's a big deal. There will be a slight fluctuations. Now, there are some general rule of thumb I've seen where it said must maintain a minimum of 10 volts or more. So it's going to vary from vehicle to vehicle. So I'm going to scroll down now. Now we see the cranking current average 18.02 amps and maximum 20.47 amps. You can do the same test with the amp clamp while you have somebody watching the numbers as the engine is being cranked over. Or you can make a video of that, and then you can replay the video and see the amperage. This machine and the amp clamp, it does pretty much the same thing. And you can also use a multimeter or a battery tester as well. So I have the incorrect amp clamp for the VAT tester. So I'm gonna use my other snap-on machine to test the amperage on this vehicle. We are going to take the readings from that VAT machine for the voltage, and for the amperage we're gonna be using the other snap-on VAT machine. Now this is my other snap-on machine, the MT3560 AVR. AVR or VAT, it's pretty much the same thing. So anyhow, I have the battery charged to 100% to 12.6 volts. Just make sure that the battery is fully charged before you perform this test. Otherwise, you are going to get a false reading. When I hooked up the other machine, I knew that something was off and was wrong, because that VAT machine was only showing 20.5 amps maximum, and that to me did not make any sense. And I had a look at the amp clamp. It's only rated for up to 15 amps maximum. Now, before we do this test, we have to make sure that the voltage does not drop any lower than 9.6 volts. However, the specification will vary depending on the vehicle. You will need to look up the specifications. So on this vehicle, it says that the voltage should not drop any lower than 11.5 volts as the vehicle is being cranked over. Now, there is a rule of thumb. Sometimes it would be no less than 9.6 volts. Sometimes it would be approximately no less than 10 volts. It's going to vary, so you would have to look up the specifications. No, the cranking amperage or the current draw should be approximately, on average, probably around 125 to 150 amps on a typical 4-cylinder engine. Now, it's going to vary depending on the engine and the power of the starter motor. Depending on the kilowatts and how much output the starter motor is capable of putting out, the readings will vary. So as you can see here, we have a fully charged battery, 12.6 volts. This is exactly on what you want before you do the test. If it's below this number, you will need to charge the battery. So I have the clamps connected to the battery and the amp clamp connected to the positive cable of the starter. You can either connect it to the positive cable here, or you can connect it to the negative cable. So I disable the EFI fuse at the bottom here. It's a 20 amp fuse, so that the engine will not start, so that I would be able to test the starter properly. So the voltage is dropping slightly. So I'm going to crank the engine over for approximately 10 seconds, and we are going to observe the amperage, and we'll probably take the maximum and the average and see how much it's putting out. So I'm going to crank the engine over now. So we saw probably on average 160 amps of cranking current, and momentarily we saw 228 amps, and then it dropped quickly, 142, 152, but I'd say the average is roughly, you can say 150 to 160. I'm just going to take 160 amps average cranking. Also, as you saw on the snap-on machine here, the voltage did not drop any less than 10.9 volts. On average, it stayed at approximately 11 volts as I was cranking the engine over. Now, the specification says 90 amps or less. I'm not too sure about that, and I really don't know if you can go by that number to what it says in the specifications in service information. But I do know that the starter motor is a 1.6 kilowatts starter motor. So the maximum output should be no more than 133.33 amps. So this one is a little more than that, 160 amps. So the starter motor is, I wouldn't say it's on its way out, but I can say that the starter is starting to get a little bit worn out. Now, the specifications on service information, it's really hard to say if you can go by that data, because sometimes it's not very accurate. So it's really hard to say. I think it's best to go by on what the starter is capable of producing, and so therefore I would expect an amperage of no more than the maximum output as to what the starter is able to put out. I wouldn't say that the starter motor is defective at this time. It's still cranking the engine over relatively okay. I was just a little concerned in the past because it was making some strange noises as soon as I let go of the key, but it doesn't happen all the time. So but I can say that the starter motor is a little bit worn out, and it's hard to say on how much longer it's going to last. Now, say that you do this test in the cold weather, and then the readings will be different. But if you want to find out the maximum output, the maximum amperage that the starter is capable of doing, you would have to check the kilowatt specification from the manufacturer. So I know that this one is a 1.6 kilowatt starter motor. So that's 1600 watts. So if you want to see on what the max amperage the starter is capable of, you would take watts divided by voltage, and you'll get the amperage. So you'll do 1600 watts divided by 12 volts of this system, and you'll get 133.33 amps. So this particular starter motor is capable of producing a maximum of 133.33 amps. That's the formula. Watts divided by voltage equals amperage. So if you have an amperage draw of above on what it's rated for, then you know there's a problem with the starter motor. So this is 133.33. Anything above that would be considered excessive amperage draw, and that's no good. However, the specification says it must be under 90 amps according to service information. Under 90 amps and a minimum of 11.5 volts while cranking. All of the specifications that I have stated here is for when the starter motor is loaded against the flywheel and or the flex plate. So what that means is I don't have the starter on the bench. It's not outside the vehicle. It's in the vehicle. So it's being loaded against the flex plate or the flywheel. So that's going to produce even more amperage, because the starter's outside the vehicle. There's no load on it if you are testing it that way. To conclude this video, I would say that the starter motor is borderline. I wouldn't say it passed or failed, but I would stay on the of caution as to it may be needing a replacement sometime in the near future, but otherwise it's still working relatively okay. Probably going to advise the customer that the starter may need replacement in the near future, but it's still okay at the moment. So now you know one way or the other on how to test the starter motor on your vehicle. That's it for today. If you enjoyed this video and found it helpful, please give it a like, and please consider subscribing to my channel if you're not already a subscriber, and I'll see you guys next time. Have a good day and take care.